Good morning, everyone. Well, it's morning to me. It's about 6:30 in the morning on Saturday. I finally found some time to do this recording. Um, so what we're going to cover today in this short video is LINQ. LINQ is a new feature that was introduced to the C# language in version 4, and LINQ, spelled LINQ, stands for Language Integrated Query. So, what is LINQ? LINQ is this concept that, as a programmer, you may not be familiar with SQL, T-SQL, SQL Server, writing queries for databases, those kinds of concepts. But there's a lot of power in a query language, especially if you're writing code against any sort of collection, be it in a database, be it an array of objects, be it XML. The ability to query and write queries provides so much more power and simplicity than what you can get from writing complex for loops, declaring a lot of variables, all of these kinds of things. So the in tandem with the creation of LINQ was this idea of creating what is now known as the entity framework. And we'll get into the entity framework next week, but the idea is to abstract away the complexities of connecting to a database, trying to make it fast, efficient, consistent across any development project, and provide good tools to developers that allows them to connect into a database, feel comfortable that the queries and calls that they're writing in C# are getting translated appropriately into database queries. So to do that, the C# team and actually the core.NET team had to go through and create an equivalent query language that would allow developers to write queries in C# or whatever their language may be, and be able to then map or translate them from the programming language into SQL, T-SQL specifically. Alright, so I'm not going to connect to a database today, but what I am going to do is I do have a collection that I'm going to use. So again, LINQ can be used on entity framework datasets. It can be used on any sort of collection or array of data. The goal here is that you're taking a group or a collection of items and you're writing some sort of query to pull elements of that data set out. So again, so you can use it on a database or you can use it on a collection of objects, which is what we're going to do today. So to start out, I went ahead and I created a student class. It has most of your basic elements: first name, last name, student ID, grade, birth date, homeroom number, address, city, state, and zip code. So just a real basic student class, nothing overly complex. There are a few additional properties in here that I'm actually not going to use, but I just feel that giving you some examples, some visuals, it's always good to see things again. So most of these properties are string properties. They all have public get sets. The exception is the date time, which is a birth date, and homeroom, which is an integer. I also created another static class called student repository, and inside of this class I did one method called getAllStudents, which returns an array of students, and then I just did the inline declaration. So first name Kevin, last name Gantos, student ID 1, 2, 3, 4, 5, 6 as a string. Birth date equals, and then this is something maybe to take note of, new birth date. So I'm actually declaring a new date time object for my birth date. My birth date is a date time type, so I'm actually in line here saying new date time and putting in some dates, comma, grade equals the letter K. So I did the same thing for everyone in here, and you'll notice that there are commonalities across some of these students. I have 2 people named Larry. I have 3 people that are all in the 12th grade. I even have, and let me make this a minor adjustment. I have 2 people, actually 3 people now that were all born in May. So these are all elements that I can then query on to pull out data, trying to do groupings and queries and things like that. All right. Now, one thing I want to make note of, and it's never expected that you're able to know everything. The internet is a very valuable tool, and it's just not physically possible to know how to write everything. So Microsoft, again, has a lot of really good samples. This 101 link samples is something that I honestly will refer to on a relatively regular basis. What it contains is sample code for writing any type of link statement you would want. So we have restriction operations, where statements, if you want to think of them that way, projections or select statements, and there are different methods of selects. There is groupings, which are group bys. You can do distincts and unions and intersections. And then there's some other things, there's order bys, and then there's some more unique things like take while and take and skip and first or default, any, all. You can do joins, cross joins, left outer joins, group joins, concatenations, aggregates, minimums, maximums, averages, sums, and counts. So there's a lot here. I'm not going to go into each one of these right now. I may refer back to it later in the lecture, but pick a specific one. But I wanted you to be aware of this. So you simply just have to, I always just query for link 101, and I'll get a Google search result. And it says 101 link samples. It's a really good resource. Link is, it's a very fun subset of tools or functions to use. It gives you a lot of just functionality and makes things a lot simpler and relatively easy to read compared to traditional declaring variables, writing for loops, and it just makes your code easier to read. Now note I'm saying easier to read. I'm not saying faster, I'm not saying more efficient. It is actually, and there are studies out there and you can look them up for yourself, but people have actually done metric analysis comparisons to using link versus using traditional variables and loops. Link is fast. Link works well, but when you are in very high performance situations where you're processing thousands of rows, tens of thousands of rows, millions of rows, link definitely shows its performance deficits. So it runs a lot slower in comparison to a traditional for loop running against an array than running some sort of a link query. So that's something to keep in mind as you're writing your code. And I'm not saying not to use link. I use link very often, and I'm actually going to show you that there's the true language integrated query syntax, and there's also link extension methods, which basically the CLR takes the queries and then converts them into these extension methods. And we're going to see how those two kind of play together. But I use them quite often. So don't be afraid of using them, but when you get to a point and you're potentially building a very high performance system, do testing. Make sure that you're not running a situation where you're actually degrading performance simply because you're using a link statement. Alright, so let's get into this. So I have a students array that I've declared. I haven't initialized it, so I'm going to say students equals student repository dot get all students. So what does that do for me? That basically is going to spit out onto the screen, or that's going to pull that array of students into my students variable. We'll do let's do this. Let's write one method, private static void display collection, and this will take an IEnumerable of student. These will be students to print. And what this method will do is simply do a for each loop. So we'll do student s in students to print. And then this will do a console.writeLine. And I'll do a string format. do parenthesis. Okay, so these are string format. So the first value 0 will be s dot first name, so the student first name, and then we'll do s dot last name and s dot student ID. And then I guess we can also do, we'll add one more, s dot birth date dot to string to short date string. And we'll add one more token here. Alright. So then here we can just simply call display collection, and we'll just pass in our collection. That way we don't have to write that loop every time we want to output the collection. So we'll also say console.writeLine. This will be all students. So this will be kind of our test scenario. So we'll run. Oh, at the bottom here I need to put a console.read. And this will stop the window from closing. So F5. So there are our 5 students: Kevin, Steve, William, Larry, and Larry P. Alright. So the first thing that we're going to do is we're going to query out all of the seniors. Now, one thing, and I think I've kind of used this occasionally in some of the lectures, but I've never really spoken about it in detail, is the var declaration. So we can say var seniors equals. Var is a infer declaration. What that means is that seniors, so when you declare a variable, students is of type student array. If we were to declare a single student, kind of like we did here in the for each loop, we said student s. So the s variable is of type student. That's an explicit declaration. When we say var seniors, when you declare a variable as a var, you have to initialize it to something. You have to put something on the right hand side of the equal sign. So if we were to put a 1 semicolon, and then we say seniors dot something, you'll notice that IntelliSense tells us that seniors is of type int. And the reason it says that is because it infers its type, its data type, from what it was initialized with. So since we put a number here, that number is an integer, therefore seniors is now an integer. If I put 0.5, seniors becomes a double. So it takes on whatever type it's initialized with. So it's a very nice feature, especially when you're working with LINQ, because you'll see later that we're going to end up with some very abstract data types, and we're actually going to be creating some kind of on the fly, and we're going to be creating collections of them on the fly. So using var with your LINQ statements is not a bad practice. It's actually what you'll see in a lot of the Microsoft example documentation, but don't confuse this with declaring vars in like JavaScript. These are strongly typed. So it's not like I can say, var seniors equals 1, and then on the next line say new student. I will actually get a compile time error saying cannot explicitly convert student to int. So it's trying to take the seniors, which is an integer variable, because we initialized it here, and it's trying to store new student into that variable, and it can't convert the student into an integer. So seniors I'm going to declare as a var, and then I'm going to write my LINQ statement. Now, LINQ statements, the syntax does vary, but the basic idea is that you're constructing a query that is pulling one item at a time from a collection. So very similar to what you see in a for each loop. The difference is that you're pulling one item at a time to either filter, group by, or select from. So the goal here is you want to be able to take a collection of items and do some sort of mechanics or some process. Alright, so we'll start with from, and then our instance variable, and we'll say s in students. and then we'll say where s dot grade equals 12, select s, semicolon. Now, if you're at all familiar with using T-SQL, you'll look at this and go, that's upside down. And the syntax is a little unusual. It feels weird, even to me, because I'm very familiar with using SQL queries and T-SQL. I always look at this and I go, this is upside down. And really, for the exception of the select statement being last, everything else you'll find as we get into more complex situations, the syntax is actually pretty on par. The select statement goes last because that is the result that is then stored inside of the variable. So we start off with our students, and we're selecting from students and putting it in S. So S is the instance variable that we're kind of dealing with throughout the rest of the query. Then we say where s.grade equals 12. And that should be pretty normal. One thing to note is that there are double equals here. Again, if you're used to writing standard SQL queries, you'll know that you only need one equal sign. But we are using C#, so to notate equality, we still do the double equals. And then we say select S. So you can read this as for each student for each S student in students, where the student grade equals 12, select that student and return it. So the end result, and I'm going to do my console.writeLine, we'll say seniors, and then we'll do display collection, and we'll say seniors, and you'll notice that the IntelliSense says that seniors is an IEnumerable of student. Now, an IEnumerable is the most broad interface type for any type of collection within the .NET framework. So that means that any arrays, collections, lists, any of those things are all based off of IEnumerable. So whenever you're trying to deal with abstract collections or unknown collections, IEnumerable is always your best bet. So that's why in our display collection method down here I said IEnumerable student, because I knew it 99% of the time we were going to get back just a collection of students, but I wasn't sure what type of collection. So what this will do is it will loop through that entire repository. If I go back here real fast, I'll show you the repository again. It's going to loop this whole repository, and it will give us back just the students who are in 12th grade. So we have 3. So if we run, and let me actually do some minor format changing. So we'll do a WriteLine, new char, I'm sorry, new string, and we will do 40 of them. So this is a neat little thing. So if you like to do, like, if you're doing a console app and you want to output a particular character for a certain number of them, if you do new string with the character, comma, the number of characters, it will actually generate a string with that number of characters. So that's a nice little feature to keep in mind. And all that's going to do for us is give us some separation between our display collections. Alright, so all students, there's all 5 of them, and then our seniors, those are our 3 seniors. I'm going to go ahead and make one more, actually 2 more adjustments. So I'm going to do pipe grade colon 3, pipe birth date colon 4. Now, these numbers designate the positions within the latter part of these parameters. So 0 is the first parameter here, 1 is this one, 2 is student ID, 3 should be grade, so I'm going to insert s.grade here, and then the 4th or 5th parameter, number 4, is s.birthdate. So that's something to keep in mind if you're using any sort of string.format or format option with the console.writeLine. Alright, so that gives us a little bit more formatting. So we can see that the 3 students that were selected are our seniors. They're all born in 1960. 2 above them were in fact born in May. So that gives us that ability to do a query. So we took the original 5, we queried only for the 12th graders, and then we got back a collection of just 12th graders. Alright, so we found all our seniors. So let's get students named Larry. So same concept, so we'll say var Larry students, and we'll say from s in students where s dot first name, and now we can also do equals Larry, and we can do this basically however we want. So that's the equivalent, and we can say select s. So again, we're pulling the student objects out for any instances where this first name equals Larry. So then we'll do console.writeLine, and we'll say students named Larry, and we'll do display collection. We call this Larry students. Okay. F5, and then what we get is the 2 students named Larry. So, pretty simple. Okay, now we're going to get into some more complex things. So I'm going to start by doing some group bys. And actually, before I do group bys, I'm going to actually insert one more thing here. So we'll say select just first name. And maybe we'll just select name. So what I'm wanting to create is a list of just names. I don't want the full object, I just need the names. So to do that, we're going to say var names equals, and we'll say from s in students. Same idea again. We'll say, we won't do a where, but we're going to do a select, and we're going to do a modified select. So we're going to select not s, but s dot first name plus s dot last name. So what this is going to do for us is it is going to do a query, and it's going to pull one student at a time from students. And then instead of returning the student, it's going to return a string that is a concatenation of first name and last name. So we'll say student names. And then for this, we're going to have to, we can't pass it to display collection because that takes an array of students and names. If we type in names here, we'll see it's an IEnumerable of strings. So I'm going to do not a shorthand, but I'm going to use the string.join method. And string.join says give me a separator string and then give me an array of objects, and what it will do is it will join all of those objects into a single string, joining them by whatever separator we choose. So I'm going to say a new line. Actually, I'll do environment.newline, comma, names. So if we run this, it should give us an output of just the names. And there they are. So if we come all the way back up to the top, we'll see all students. There's all 5 of them. Seniors, the 3 seniors. Students named Larry, the 2 Larrys. And then here are all the student names. Same 5 names. Now we can go one step further here, and we can say from students S, order by s dot last name, and run it again, and it will actually sort them by last name. So we start out with Ellison, then Gates, then Gantos, then Jobs, then Page. So this order by gives us the ability to do some level of sorting. We can say last name, or s dot last name, comma s dot first name, sort again, and we probably don't have enough differentiation there to warrant a first name sort. But if we had two with the same last name, then we would end up with sorting by last name then first name. We can also flip this around, and we could say first name, comma s dot last name, just so you can see difference. So now they're sorted by first name. So there's Kevin, 2 Larrys, Steve, and a William. So that gives us another form of querying. So we're querying we're basically doing kind of a selection of elements from student and pulling that back. Additionally, we could do another slightly more modified version of that, and we could say, well, we need a new object. We want to create kind of like a slimmed down student object. We don't need all of the data, we just need the first name, the last name, and the student ID. So we can actually go in here, and let's do select student name and ID. So we'll say var name and ID equals from S in students, order by S dot last name, select new, and this is called an anonymous type. So what we can do here is we can say S dot first name, comma S dot last name, comma S dot student ID. And what that is going to do for us is it's going to create a type, a class. The compiler is going to create us a class. And then what we're doing is we will then use that array of that type, and it's being stored inside of name and ID. So this is where the var starts to come in very handy, because we don't actually have to declare a class. We don't have to create a new type. We don't have to do all of that work. We're actually letting the compiler create a type for us temporarily. And that type will have 3 properties. It'll have a first name property, a last name property, and a student ID. And then all of those will then get wrapped up together into a single array or collection of this type that has these 3 properties. So if we do the same kind of thing that we did before, so we'll do a string join, and we'll do it on environment, new line, that'll be our separator, so we can get a printout of our string. And then we'll do a string.format. So that'll be first name, last name, student ID. So then what we will do here, that actually won't work. I apologize. We'll have to do a full for loop. So we'll do for each var item in name and ID. So we can use the var there as well. So basically every item inside of this collection, and you'll notice here that this collection is IEnumerable of single quote A. Every anonymous type is basically given this single quote in a letter. And it even says that it is an anonymous type, and it is a new first name, a string first name, string last name, string student ID. The properties are inferred by the properties that were passed in. If we want to make it explicit, we can say first equals first name, last equals last name, and ID equals student ID. So then when we say item, the properties we get are first, last, and ID. You also notice that equals, hash code, get type, and toString are here. If you remember from our very first set of lectures, I talked about how everything inherits from objects. So these methods come along for the ride because these are base class methods in the object class. So they're always there. We didn't code them, they just appear because everything inherits from object. Alright, so we will do a console.writeLine of item dot first plus item dot last plus, and then in parentheses, item dot ID. And again, remember that first, last, and ID exist because we did first, last, and ID. If we were to remove this first equals, last equals, and ID, then our properties, and I'll go ahead and actually show you this, revert to being not first, but first name, last name, and student ID. So if we run now, oh, I need to put some spacing. So we'll do right line, new string, 40, line break, and we'll run now. So up here at the very top, we have all students, seniors, students named Larry, student names, and student NID. I neglected to put a space in there, so they run together. So there's the appropriate spacing. Alright. Alright, so the last two samples I want to show you are groupings. So we can go in and we can group our objects. To do this, we start out with declaring the same, so students by birth year. So from S in students, and again remember that S is the single item that we're working with inside of the student's collection. We'll say group S by S dot birth date dot year into, and then I always use some sort of notation like G students. So what this line is saying is group S by the birth date, year, and put that grouping into G students. So it's kind of almost like a sub-select, but it's doing groupings. And then we can say select new, and then we'll say year equals gstudents.key. So the key of this grouping, and it's of type I grouping, the key is whatever we're grouping by. In this case, it's the year. So the year is an integer. You'll notice that the key is also an integer. It's because that key is the year. Now this is where it starts to get a little abstract, and this is just a convention that you need to kind of learn. And then we'll say students equals G students. And what G students is the collection of students. So the I grouping object consists of two pieces, a key and a collection of students. There is no actual values property, you just take the grouping itself. And what we're creating here is we're creating a new object that has a year, a property year, and a property students. In this new object, we will then get back an array of them inside of students by birth year. So then when we actually do our output, we're going to have to do another for each loop. So if our item in students by birth year, and if you're curious what that was, I did for each, double tab, and it gave me the template. And then what I can do here is I can say console.writeLine, and I'm just going to start out by printing out the year. So item.year. And then I'm going to do another CW, and I'm going to do a new string dash, I'm going to just do 10. And what I'm doing here is I'm actually going to, this will print out each year that was created in the grouping. It's not going to print out the students, it's just printing out the years. So if you think about how this is structured, what is inside of students by birth year? You actually have an array of this object. And each item in students by birth year has two properties. It has a year, and then it has another sub-collection of students in that year. So the first for each loop is simply going to loop through 1 year at a time. So if we do a run, you'll see that it prints out 1980, 1960, 1970. So those are the 3 years that exist within my repository. 1980, 1960, and 1970. So it's just spitting out for us those years. So if we needed to grab all of the years that the students were born, we didn't care at all about the students themselves, we just needed those years, then this is what we need. We have that data. But what we actually want is we want more data than that. We want to have each group of students by year. So I'm going to make 2 adjustments. The first adjustment is I'm going to add an order by here, and I'm going to say order by s.year. Not there. I'm going to do order by s.year.birthdate.year. You can't do it in the grouping because once you do the grouping, well, we might be able to do gstudents.key, so we could order by that way. So we can do the groupings, order the groupings by the key, and then if we do a run again, we'll get 60s, 70s, and 80s. So that works just the same. We could sort the collection first, but doing it by the grouping is probably slightly more efficient because we're sorting 3 items instead of sorting 5. Alright, so that was my first adjustment. Second adjustment is output students. Now to do this, we're going to do another for each loop, and we're going to output every student in item.students. So we'll do a console write line. I'm going to precede it with a dash, and then I'll do plus s.firstname plus s.lastname plus s.studentID plus, there we go. So this will then print out for us that group of students by year. I'm going to go ahead and add another line break just for some separation. And what this will now give us is it'll spit out the year, and then it will spit out each student in that year. It'll add a line break, and then once we're done with our loop, we'll do that final footer. So if we run, if we scroll back up to the top, all students, seniors, students named Larry, student names, student IDs, and then we have students by birth year. Actually, before we get into that, maybe I should make one more accommodation. Let's do a pipe space plus, and then we'll actually output the birth date. That might be a value to us just to verify. Okay, so students by birth here. 1960s, we have Steve Jobs, William Gates, and Larry Ellison, all born in the 60s. 70s, we have Larry Page, and then 80s, myself. So this grouping has grouped these students by their birth year. Alright, so same concept again, so it'll be var students by grade equals from S in students, group S by S.grade into G students. So we have a group of students. We can do an order by again. G students.key. So we're going to now sort by the string key, or key is of type string, and that key is the grade. And then we'll select new grade equals G students.key, comma, students equals G students. And then I'm going to go ahead and actually copy and paste this work here. So what adjustments do we need to make? Item no longer has a year. Well, first of all, we need to have students by grade. So that's going to cause this to no longer be year, but it will now be grade. And then everything else, honestly, should stay the same. The only thing we may want to adjust here is the output of the actual grade, so s.grade, so we can see the grade level. So I'll add a header here that'll say students by grade, and we'll run. So we now have students by grade. You'll probably think, well, why did it sort 12th grade, 7th grade, kindergarten in that order? These are all strings, so the way it's sorting is it's sorting by first character. So the 1 precedes the 7 precedes K. Numbers sort above letters. So if these were actually numbers, or we had some sort of sorting index, then these would sort as you would expect kindergarten, 7th grade, 12th grade. But because we're using strings, they come out in this order. So 12th graders, 7th grade, Larry, kindergarten, myself. So that is a basic overview of LINQ. One other adjustment or sample I just want to give you, I'm going to go back up here to the very top, and I want to look at Get All Seniors again. And I want to do a modified version of Get All Seniors. I want to talk real quick about those extension methods. So Get All Seniors with extension method. So our collection of students is called students. And instead of so we can declare variable seniors 2. And instead of doing a from and all of that stuff, this is actually my preferred method, only because I feel like it's a little more consistent with the rest of the language. What I like to do is I like to do students, and then utilizing the LINQ extension method off of any collection, as long as you have the system.link namespace included at the top. I'll show you that. As long as you have this namespace included, any collection will show with this set of extension methods. And you'll notice some similarities here. You'll see things, let me actually go to the bottom, because you'll see select, and you'll see where. You'll also see things like order by and order by descending, and group by. These methods map to the LINQ statements. So we can say students.where, and then we're using a lambda expression, which, if you want to mimic the two or mirror the two ideas, we always say from S in students. So we're going to say here where S equals sign greater than, which gives us an arrow, we'll say S.grade equals 12. Now, to me personally, and you can tell by the number of lines, that's a lot shorter than writing from S in students where where S.grade equals 12, select S. This generates the exact same work. It generates for us a collection of students. So then we can simply say seniors 2.0, display collection, seniors 2, and this will give us the exact same output. But we did it in one line instead of 4. So again, this is my preferred way of using LINQ. They are the same. Sometimes when you get into very complex queries, where you're doing a lot of grouping and a lot of other work, this does become cumbersome, but it's a give and take. It's kind of preference and the way that you prefer to do things. But they are the one and the same. One is just one type of syntax, one is a different type of syntax. Just to give you one more quick example, let's say we just wanted to grab, we wanted to create that new object of just student name and grade. We can say students dot where student grade equals 12, and then we can actually go on and we can append to this. So I could do it in line up here and say select s dot first name. Or we'll do a new object, so we'll say new object s dot first name, s dot last name, s dot grade. What this is going to do for us now is seniors becomes an anonymous type with those three properties: first name, last name, grade. We would have to then write a quick for each loop. Item in seniors 2. And then we'll do console.writeLine item.first name, item.last name, item.grade. We'll run that, and that will give us our seniors. So these are different options again. LINQ is one of those things I will say that you get more comfortable with the more you use it. So I would recommend, doing like I did. Go in, create a small project, create a class, create a repository, a collection of that class, and then just kind of hack at it. Do different groups, do different group bys, select statements, where statements. If you have two collections, and you'll see this in the LINQ, the 101 LINQ examples, you can do nested froms. So if you have two collections of objects, or you have a collection of nested collections, you can say from collection A, and then you can say from B in A dot, and then some property, and you'll see those in here. I don't remember exactly where they are, but you can, if you have any questions, you're interested in it, by all means, feel free to ask me. I'll try to use an example next week. So this is LINQ. This is how you do LINQ. This project will be posted up on Blackboard, so if you want to kick through it in more detail, by all means, feel free to. Thank you very much. Have a good week.